Good evening. Sorry for the little bit technical issue, my dear students. Okay, myself is Dr. B.N. Rao, my dear students. Okay, having 17 years of the pure teaching experience, my dear students. And from the last 10 years, I was supposed to be teaching the various subjects in the departments of electronics and communications and instrumentation, my dear students. The subjects like communication systems, core instrumentation, electronic device, and VLSI design, my dear students. Okay, these are all the important subjects. Just I would like to bring it to your notice over here. Okay, similarly, okay, out of that 10 years of experience, I dealt nearly 200 plus batches across 200 plus batches, my dear students, across all the locations of the India, my dear students. Okay, across all the locations of the India, my dear students. Okay, recently I received the PhD in the department of ECE under low power VLSI design, my dear students. Okay, similarly, okay, today's session I am going for the very important session. Before going for that particular session, let me depict you about okay, Unacademy. Okay, Unacademy is having two important subscriptions, my dear students. One is iconic subscription and second one is the plus subscription. Okay, as an iconic subscription, my dear students, if you are going to take this particular subscription, a personal coach is dedicated for each and every student. He will depict you the subject in a detailed manner, starting from the basics to the end, detailed problem solving, detailed model problems, all those things, my dear students. Okay, and a detailed study plan also that is going to be present over here, my dear students. Okay, moreover, you are going to receive the expert guidelines from the topmost educators of the Unacademy, my dear students, and the main levels guidance also, engineering services main levels guidance also you are going to get over here, my dear students. Okay, similarly, when it comes to the plus subscription, if you are going to take this particular plus subscription, my dear students, you are going to access the live classes from the topmost educators of the Unacademy, my dear students. Okay, and you can practice unlimited test series with respect to the structured timetable, my dear students. Okay, these are all the important parameters. Just I would like to bring it to your notice, my dear students. Okay, so and iconic subscription itself is a very dedicated subscription. If you are going to take this particular subscription, my dear students, the very important thing itself is that a dedicated, okay, so you are going to move out, okay, with a good rank in the GATE exam or the engineering services, my dear students. Okay, GATE and engineering services, my dear students. Okay, similarly, when it comes into the GATE and engineering services, for plus subscription for 12 months, the fee structure is 27,225 and you can use my code and get the discount, my dear students. Okay, very important one. Similarly, when it comes into the plus subscription, my dear students, for 18 months, 34,650, you can use my code and get the discount. Okay, similarly, for 24 months, the fee structure is 39,600 and you can use my code and get the discount, my dear students. Okay, for the same plus subscription. Okay, similarly, for the iconic subscription, my dear students, for 12 months, the fee structure is 45,225 and you can use my code and get the discount. Okay, similarly, for 24 months, for the same iconic subscription, the fee structure is 66,600 and you can use my code and get the discount, my dear students. Okay, similarly, these are all the subscriptional details, my dear students. Similarly, the plus batches taken by the top educators inside of the Unacademy subscription in the departments of EC and electrical, my dear students. Very important is target engineering services films 2021 batch D and rank booster batch for GATE 2021 batch D and target engineering services films 2021 batch C, my dear students, and the rank booster batch for GATE 2021 batch B, my dear students. Okay, all these batches are going to be taught by these particular top educators, and some batches already started in the November and some batches has been started in the first week of the December. Okay, and there are certain batches that has been started, my dear students, the ascent for the GATE 2023. Okay, batch A, my dear students, English and Hindi starts on the 21st of the December, my dear students. Okay, similarly, ascent for GATE 2023 for batch A English and Hindi, my dear students, starts on the 21st of the December, my dear students. This particular batch also. Similarly, evolve for the GATE 2022. Okay, batch A, my dear students. English and Hindi starts on the 21st of the December, my dear students. Okay. Similarly, evolve for the GATE 2022. Okay, batch that is also starts on the 21st of the December, my dear students. Already all these particular batches has been started in the last week of the last year, my dear students. Okay. Similarly, GATE crash course has been started and running successfully, my dear students, and this is the closing ceremony, and the rest previous year questions I'm going to do in the, my dear students, in the very important in the special classes, those who has interested. Okay, I will keep the links, my dear students. So okay, we are closing by this particular today, my dear students, for this particular GATE crash course, my dear students. Okay, so at the rest topics, the students who are having the interest has to attend the special class, my dear students. Okay, and Unacademy December month is almost completed, my dear students, and a crash course for the EDC is going to close by today, my dear students. Okay, today by itself. Okay, at the rest topics, the people who are having the quite interest has to come into the app class, my dear students. Okay, good evening, Monica. Good evening. And my dear students, I told you that I already finished all the things, my dear students, up to here in the previous class. Okay, now in this particular session, my dear students, I have started the Zener Diode. Okay, in the previous class. Okay, so what kind of parameters we have studied, my dear students, in the Zener Diode? Okay, under Zener Diode, so always what is Zener Diode, I told you in the previous class, my dear students. Okay, I told you about the Zener Diode. Okay, and very important itself is that very important is Zener Diode. All these things has been finished. Last class I have started with the Zener Diode, my dear friends, and this particular diode I finished the concept. Go for the recording, my dear friends, and I finished about the breakdown mechanisms in the Zener Diode, my dear friends, and the VI characteristics also I have finished in the previous class, my dear friends. Okay, and the equivalent circuit of the Zener Diode, my dear friends, we are over here, my dear friends. Okay, already we have done all the things, my dear friends, as far as the Zener Diode is concerned. Okay, generally I told you in the last class, my dear friends, the Zener Diode, the equivalent circuit. Before going for the equivalent circuit, generally the Zener Diode is having the two types of currents, my dear students. One is called IZ minimum and second one is IZ maximum. Okay, up to here I have finished. Okay, IZ minimum. What is IZ minimum, my dear students? Minimum current, the minimum current through the Zener Diode, my dear students. Okay, to maintain its reverse breakdown operation. Okay, I told you in the previous class what is IZ minimum means, my dear students. The minimum current through the Zener Diode to maintain its reverse breakdown operation, my dear students. Okay, to maintain its reverse breakdown operation, my dear students. Okay, and IZ max, I told you this particular one also in the last class. Okay, IZ max, my dear students. Okay, this also I told you. Okay, IZ max is the maximum current where the Zener Diode can safely maintaining its reverse breakdown operation. Okay, minimum is this one, maximum is this one. Okay, both these are for the what, my dear students, for the Zener Diode to operate, my dear students, in the reverse breakdown. Okay, Zener, that is Zener Diode, my dear students, I am going to operate in reverse breakdown. I am going to operate, my dear students, in the where, in the reverse breakdown. Up to here I have finished, my dear students. Okay, reverse breakdown, my dear students. Okay, I told you one more important thing. See, for any particular diode, the load is also present for any particular diode. Okay, and these particular formulas also I told you. Once again I am reminding here, what is IL minimum, the load minimum current, IL minimum, my dear students, which is equal to I minus IZ max. Okay, I minus IZ max, my dear students. Okay, similarly IL max, which is equal to I minus IZ minimum, my dear students. Okay, IZ minimum my dear students. Okay, these are all the important parameters which I had finished over here, my dear students. Okay, over here IL max, IL min and IL max, my dear students. Okay, I equal to IZ max and I equal to IZ min, my dear students. Okay, very good. I told you, Monica, very good, very good. Okay, now in this particular class I am going to show the equivalent circuit of a Zener diode, my dear students. Okay, and what are the practically the Zener has its own internal resistance, and what is this I am going to explain. Listen carefully before going for the problems, my dear students. Okay, before going for the problems. Okay, very important, my dear students. Okay, this is what, my dear friends, you are getting. This is the Zener diode and its equivalent. Okay, the circuit model I am representing, my dear friends, in a very important manner. They see I am representing over here, my dear friends, in a very important way. This is Zener diode, my dear friends, which is the voltage across the Zener diode is Vz, my dear friends. Very important. You have to remember all these things, my dear students. Okay, very important. And here this ZZ, my dear students, and this is a ZZ. Okay, practically very small, mean though very small, Zener has an internal resistance. Okay, the resistance of the Zener diode, my dear students, always it is having a very small internal resistance. Okay, so in the Zener, because we are operating in the reverse breakdown, we are operating in the which quadrant, my dear students? In the third quadrant. Okay, third quadrant. This resistance is called dynamic resistance of the Zener diode. This one is called the dynamic resistance. Dynamic resistance of the Zener diode, my dear students. Okay, very important one. You need to remember, because here what I am going to tell you, I am going to operating in the which quadrant, my dear students? In the third quadrant. I am going to operate in the third quadrant, my dear students. Okay, when I am operating in the third, that is third quadrant, see here, this is like this. This is like this, my dear students. We are going to get in such a fashion. Okay, in such a fashion. See here, if I am going to take it up to here, listen carefully. This is what I am expecting here, and here this is the change. This is whatever the change I am going to take it, leave it here, my dear friends. See here, see here, my dear friends, very important one. This is what, my dear friends. Okay, this is change in IZ. Okay, this is the current axis, and I told you that the minimum, okay, the minimum current that is going to be, and this is the change in Zener voltage. Change in the Zener voltage. This is the third quadrant, my dear students. Okay, what are the parameters I taken? Like this. This is what, my dear students. Okay, listen carefully. What I am teaching is very important, my dear students. Over here, my dear students. Okay, so practically I told you that this resistance is called the dynamic resistance. Practically Zener region is not exactly vertical. It is not exactly vertical, my dear students. Okay, Zener region is not exactly vertical. There is a small change in the Zener current, and that one is delta of IZ. Okay, and there is a small change in that is Zener voltage, that is equal to this one. And the ratio, my dear friends, okay, the ratio of which one is called the Zener resistance, means the Zener resistance is ZZ. Okay, the dynamic resistance, okay, the dynamic resistance is denoted by Z, my dear friends. Okay, ZZ. ZZ equal to delta Vz divided by delta into Iz, my dear students. Okay, which is equal to very important. Okay, so here practically Zener equivalent circuit is shown with what, my dear students? This is equivalent circuit, my dear students. Okay, is shown with the, see here, a battery of Vz, and we are representing with the dynamic resistance, my dear students. Okay, if I am writing the reverse, okay, if I am writing like this, my dear students, 1 divided by my dear friends, slope of the reverse characteristics in Zener region, okay, which is equal to slope of the reverse characteristics in Zener region, my dear friends. Okay, reverse characteristics in Zener region, we can write down like this also, my dear friends, which is nothing but the slope. Okay, so we are representing in this can also be written, my dear friends. Okay, 1 by means this complete parameter, my dear students. Okay, this is the complete parameter we are representing. This is the complete parameter, my dear students. Okay, is that clear up to here, everyone? Okay, is that clear? Okay, so I am representing here. So ZZ can also be written as like this. Okay, ZZ equal to, my dear students, 1 divided by my dear friends, very important is the delta Iz by delta Vz, like this also you can write down. Okay, which is nothing but what, my dear students? Same as this one, my dear students. Okay, same as this one, my dear students. Okay, these are all the important parameters, just you need to remember. Now very important parameters, I am going for the Zener diode ratings. What are these particular Zener diode ratings, my dear students? Okay, Zener diode ratings are very important over here. Okay, first one is the Zener voltage. Zener voltage, my dear friends, it is a normal working voltage of the Zener diode. Okay, normal working voltage of the Zener diode, my dear students. Okay, which is specified at the that is it is specified, my dear friends, at a specific value of the Zener test current. Okay, at the specific value of the Zener test current, my dear students. Okay, and very important over here. Okay, this is the Zener voltage. Okay, and the Zener test current can also be represented by Iz, or these are all the parameters you have to remember before going to solve the problems. Okay, Iz, or we can represent IZT, my dear friends. Okay, see here, Iz is a normal working current of the diode, my dear friends. It is a normal, that is working current of the diode. This current is also called Iz, or it is also represented by the Zener test current, my dear friends. Okay, similarly, okay, second parameter is over. Okay, third parameter, dynamic resistance, that is also we are seeing now only we are seeing the dynamic resistance, my dear friends. And fourth Zener rating is what, my dear friends? Iz min. What is Iz min? Means the minimum current, my dear friends, the minimum current the Zener diode to maintain its reverse breakdown operation, I already told you. And fifth one, Iz max, my dear students. Okay, what is Iz max? That is the maximum current the Zener diode can safely, you can operate without exceeding its, okay, without exceeding its maximum power dissipation limit. Okay, maximum power dissipation limit, my dear students. Okay, sixth parameter PD, power dissipation. Okay, what is this power dissipation? It is a product of the Zener voltage. Okay, that is Vz into Iz, Zener voltage into Zener current, my dear students. Okay, like that. Okay, and the last one is the, see here, when the Zener diode is going for the beyond the reverse breakdown, then this particular parameter is getting, and this is what PD max. What is PD max, my dear students? PD max ante what is this? PD max means the maximum power which Zener diode can dissipate safely. The maximum power which Zener diode can dissipate safely, my dear students. Okay, dissipate safely. It is the product of what, my dear students? VZ and IZ max. Not IZ. VZ and IZ max, my dear students. Okay, like that you are getting the different parameters over here, my dear students. Okay, all these are all the important parameters you have to remember over here. Similarly, applications of the Zener diode, very important. Okay, where we are using this particular one, my dear students, applications. Okay, very important applications, my dear students. Okay, Zener diode applications are very important. Okay, the first application, it acts as a Monica. It acts as a Zener diode, acts as a voltage regulator. Voltage regulator, my dear students. Okay, in voltage clipper circuits. In voltage clipper circuits, my dear students. Okay, in voltage clipper circuits, and here next one itself is clippers and clampers. Okay, this thing also. Next one is for controlling the output amplitude. Controlling the output amplitude, my dear students. Okay, as a reference voltage in comparator circuits. As a reference voltage in comparator circuits, my dear students. Okay, comparator circuits. Okay, and last one itself is, my dear students, as a standard voltage source in calibrating what, my dear students. Okay, in calibrating the instruments. Okay, it acts as a, my dear students, very important one. Okay, it acts as a, okay, the calibrating means voltage source in calibrating the instruments. In calibrating the instruments. In calibrating the instruments, my dear students. Okay, these are all the important parameters, just you need to remember over here, my dear students. Okay, very important parameters. Okay, just I would like to bring it to your notice. Okay, now we are going for the problematic part, my dear students, in the Zener diodes. Okay, now we are going the question, the first question, my dear students. Okay, in the following limiter circuit, the input voltage Vi equal to 10 sine, okay, is applied, my dear students. Assume that the diode drop is 0.7 volts when it is forward biased. When it is forward biased, the Zener breakdown voltage is 6.8 volts. The maximum and minimum values of the output voltage respectively are, okay, respectively are, my dear students. Okay, this is asked. Monica, are you listening? Monica, are you there? Okay, this is asked in GATE 2008. GATE 2008, my dear students. Okay. My dear students, okay. Very important parameters, just I would like to bring it to your notice over here. Okay, see here, this is the question, my dear students, which has been asked in the previous paper over here. Okay, now the very important questions also we are going to do. Okay, listen here, my dear students. This is the circuit which he has given, my dear students. Okay, now in this particular circuit, Vi is the input voltage, my dear students. Okay, this is the input voltage, my dear students. Okay, the input voltage is what? This is, okay, Vi. This is what he has given, my dear students. Okay, this is the thing that he has given, my dear students. Okay, assume that the diode drop is, okay, the diode drop is 0.7 volts. Here the drop is itself is called 0.7 7 volts when it is forward biased, and the Zener breakdown, okay, is my dear students, it is the Zener breakdown voltage, my dear students, okay, VZ he has given, this is equal to 6.8 volts, my dear students, okay. The maximum and minimum values of the output voltage, he is asking what is the maximum output maximum and what is the minimum, my dear students, okay. First listen carefully, see here, for the positive half cycle, because what kind of wave I had given, the sine wave, my dear students, okay. I had given a sine wave, my dear students, okay. Listen carefully, this is a sine wave I am going to give over here like this. This is a sine wave, my dear students, okay, during the positive half cycle, okay. What happens during the positive half cycle, my dear students? D1 is in forward bias, okay. This D1 will be in forward bias, my dear students, okay. It is forward bias, okay. Similarly, Zener diode is in breakdown, and this is a Zener diode is also in where, my dear students? This one is in a breakdown, okay, breakdown. When it is forward bias, it means what happens, my dear students? This is okay, D2 becomes the reverse bias. This is becoming the reverse bias, my dear students, okay. Only the complete voltage, this both voltages, my dear students, okay, which is equal to maximum voltage, okay. The maximum voltage V max, my dear students, the combination of these two, that is equal to 0.7 voltage drop plus again this both, okay, plus 6.8 plus 6.8, which is equal to 7.5 volts, my dear students, okay. 7.5 volts, my dear students, okay. Similarly, okay, this is what I had given for negative half, my dear students, okay. I am going for the negative half. When I am going to take this negative half, my dear students, this one will be reverse bias. This time this is becoming the reverse bias, my dear students, okay. When this one is becoming the reverse bias, there is no flow of current over here, even in the Zener diode also, okay. No flow of the current, and D2 becomes a forward bias. D2 is becoming the forward bias, my dear students, okay. Then the output voltage, but this is given, the symbol itself is here, this is positive and negative, okay. The negative of the current, so the minimum current that is flowing is V naught of minimum equal to how much, Monica? How much the minimum current, my dear students? What is the minimum current, my dear students? What is the minimum current, my dear students? The minimum current itself is how much? That is minus only this negative, okay, minus 0.7 volts, minus 0.7 volts, my dear students, okay. These are the important parameters, just you need to remember over here, my dear students, okay, based upon this particular problem. So answer is 7.5 is maximum and minimum is minus 0.7, my dear students, okay, about this particular problem. Similarly, next question, my dear students, the previous year question on the Zener diode, okay. This particular question, my dear students, has been asked, okay, in the paper in GATE 2015 set number 1. Yes, minus Monica. GATE 2015 set number 1. GATE 2015 set number 1, my dear students, very important question, okay. He has given that the Zener diode is ideal, and a Zener voltage is 6 volts, my dear students. The output voltage V0, the output voltage V0 equal to how much, my dear students, is asking, okay. See here, the voltage across the Zener diode, okay. I want to calculate the voltage across this particular Zener diode, across this one, okay. And that particular parameter is very important, my dear students, okay. See here, the voltage across the Zener diode itself is very important over here. What kind of voltage you are getting? The voltage itself is the formula V equal to, my dear students, that is this particular parameter itself is what, my dear students? The output voltage. What kind of voltage? The complete. So here this is input voltage, my dear students, means this is input voltage V in, okay, V in divided, my dear students, into This one is R1 and this one is R2. Okay, this is R2, my dear students. Okay, R2 divided by R1 plus R2, my dear students. Okay, then the voltage across the Zener diode, you are going to get what, my dear students? The voltage across this particular Zener diode is represented by Vz, and this particular Vz you are getting, my dear students, is how much? How much, Monica? 10 into 1 divided by, okay, 1 plus 1 kilo ohms only. It is completely you are getting 5 volts. Okay, 5 volts. But see, always I told you, my dear friends, okay, Monica madam, I told you in the previous session, always Zener breakdown and the comparisons I told you. Okay, what is the minimum voltage? The breakdown occurs in Zener breakdown is less than 6 volts. Less than 6 volts. For avalanche, the Zener breakdown is greater than 6 volts. But here what happens, my dear students? The Zener breakdown voltage. So here whatever the voltage you are getting is 5, which is see, that is breakdown voltage. The Zener breakdown voltage is 6 volts, my dear students, less than 6 volts. Okay, this is the one. But whatever the value you are getting, Vz, my dear students, which is less than Vz of breakdown. Breakdown, my dear students. Okay, then what happens, my dear students? In not only asking the what is output voltage, the output voltage is 5 volts. He is asking the diode is in which state. Okay, see, the diode will be in off state, my dear students, because it should be less than 6 only. If the value is greater than 6, then it will be on state. Okay, it will be on state. But here this is what, my dear students, diode is in off state. Diode is in off state, my dear students. Okay, similarly, previous year questions on the Zener diode, my dear students. Okay, next question. We are going for all these questions are the very, very important questions, my dear students. Okay, next question. What is the next question, my dear students? This is asked in GATE 92 paper, my dear students. Okay, listen carefully. The 6 volts diode is shown below, has a zero Zener resistance, has a knee current of 5 milliamperes, the value of R, so that the voltage across does not fall below 6 volts. Okay, which does not fall the below 6 volts, my dear students. Okay, very, very important one. Just you need to do this particular one also in a detailed manner over here. Okay, in a detailed manner, my dear students. Okay, listen here. Knee current means always here the important parameters just I am bringing over here. Okay, the knee current means always the knee current is nothing but the minimum current that starts here. Knee current is always what, my dear students? Minimum current. Okay, knee current, which is equal to Iz min. Iz min equal to 5 milliamperes. 5 milliamperes, my dear students. Okay. This is the 5 milliamperes. You only given, my dear students. And the voltage across the Zener diode does not fall. Means Vz equal to 6 volts. You only given, my dear students. Okay. He has given the 6 volts over here, my dear students. Okay. Now what is the first, the total current? We need to take it. Always listen here. This is the input and this is output, my dear students. This formula, whatever the formula writing is very, very important, my dear students. Okay, and that particular is pretty important. Okay, and that particular current is I, the total current, which is equal to V in minus V naught divided by what, my dear friends? Divided by simply, okay, the parameter itself is what? What parameter, my dear friends? Okay, divided by complete resistance. Okay, and these particular resistance also very, very important over here. That is R. This one is R, my dear friends. Okay, which is equal to R. Then I means whatever the parameter I taken is I, which is equal to, okay, V naught, V in minus V naught. Okay, what is V in, my dear friends? V input. okay, which is equal to 10, my dear students, minus V naught 6, my dear students, divided by 50. Divided by 50, my dear students, divided by 50, okay, and this one itself is called 80 milliamperes. 80 milliamperes, my dear students, okay. You are going to get the current is I value you are getting, but he is asking the what, my dear students, IL max, okay. He is asking the, okay, what he is asking, my dear students, in this particular question, okay, the minimum value of R. The minimum value of R is needed, okay. This I want to bring back means first I need to calculate what I L max. IL max equal to I minus IZ min, and IZ equal to what, my dear students, 80, okay. 80 milliamperes is what you are getting, okay. IZ min is this one, 5 milliamperes, which is equal to minus 5 milliamperes, my dear students, then it equal to 75 milliamperes. 75 milliamperes, my dear students, okay. And the minimum value of the R equal to, minimum value of the R equal to V naught divided by IL max. IL max, my dear students, which is equal to 6 by 6 divided by, my dear students, 75. IL max is how much you are getting? 75 milliamperes. Then you are getting the 80 ohms. Is that clear, my dear students, what I have done? Is that clear, Monica madam, over here, my dear students, okay. Very important over here, my dear students, okay. Similarly, I am going for the next problem. So answer itself is what? 80 ohms. C. Next question. The previous year questions, my dear students, on Zener Diode. Zener Diode, my dear students. Previous year questions on this particular Zener Diode. Next question. This is our GATE 96 paper. A Zener Diode in the circuit shown below has a knee current. My dear students, of 5 milliamperes, and the maximum allowed power dissipation which is equal to 300 milliwatts. What are the minimum and maximum load currents that can be drawn safely, keeping the output voltage V naught to be constant, okay. V naught to be constant, my dear students, okay. And this question he has given the 4 options like this, okay. 0 milliamperes 180, 5 milliamperes 110, 10 milliamperes 55, 60 milliamperes 180, my dear students, okay. Like that he has given, my dear students, okay. Now in this particular question, now what he is asking, okay, that is also very important, my dear students, okay. Listen. Knee current ఇక్కడ కూడా ఇచ్చాను మళ్ళీ ఏమి ఇచ్చాడు ఇక్కడ నీ కరెంట్ ఇక్కడ ఉంది నీ కరెంట్ అంటే మినిమం కరెంట్ మై డియర్ స్టూడెంట్స్ ఓకే IZ min equal to 5 milliamperes, okay. And power dissipation max, PD max equal to 300 milliwatt, okay. He only given the power dissipation where he has given this parameter. He only given, my dear students, okay. PD max, okay. Output voltage V naught is a constant. He only given 6 volts, okay. Output voltage equal to 6 volts, my dear students. He only given, okay, this particular parameter over here, okay. Similarly, now he is asking the what are the values of IL max and IL min. He wants this one, IL max, IL min, he is asking, Monica, okay. Then what I am going to do means, see here, I want to calculate first IZ max, okay. How to get the IZ max I told you, my dear students, okay. You forgot it, my dear students, okay. PD max formula cheppanu kada, PD max which is equal to, okay, PD max which is equal to what, my dear students, Okay, what parameters? Very, very important. Okay, so PD max equal to IZ max, my dear students, into Zener voltage VZ, and but that particular Zener voltage is nothing but VZ, my dear students. Okay, same, both are same only. Okay, so V naught or VZ both are same only, my dear students. From this IZ max, okay, you are getting the IZ max outside, my dear students. Okay, to bring back the IZ max outside, that is 300 milliwatts divided by 6, my dear students, which is equal to 50 milliamperes. 50 milliamperes, my dear students. Okay, you are getting this one. This is over. IZ max is getting. But to calculate IL max and IZ max, we want what, my dear students? We want the current. Okay, and that current equal to, I told you, this is input and this is output. Okay, and this is output, my dear students. Okay, I told you what is the current formula. In the mundu chesam kada. V in minus V naught divided by R. Then I equal to 9 minus 6 by 50. My dear students, okay, where you are getting this particular parameter equal to 60 milliamperes, which is equal to 60 milliamperes, my dear students. Okay, you are going to get in such a fashion over here. Okay, similarly, is that clear, my dear students, up to here, everyone? Is that clear, my dear students, up to here, everyone? Okay, now we got the parameters. IL min. Okay, we got the IZ max value also. IZ max equal to 50 milliamperes, my dear students, and IL, okay, current I also are getting how much, which is equal to 60 milliamperes, my dear students. Okay, then IL min and L max. IL min equal to I minus IZ max. I minus IZ max. Then it will become 60 minus 50. Then you are getting this one is 10 milliamperes. Okay, and similarly IL max equal to I minus IZ min. Then it will be, my dear students, 60 minus 5, which is equal to 55 milliamperes. 55 milliamperes, my dear students. Okay, like that you are getting. Like that you are getting, my dear students, over here. Okay, similarly, completed, my dear students, maximum and minimum values. Okay, so answer is what, my dear students? 10 milliamperes, 55. See. PYQs, that is the previous year question again, my dear students, which will be asked this question in GATE 2002, my dear students. Okay, GATE 2002, he has given, I told you that the Zener diode is using as a regulator. Okay, which is using as a regulator, my dear students, and this question itself is the very, very important question, that is 13, my dear students. Okay, listen carefully. See here, my dear friends, he has given the question like this. He has given the load resistance. He has given the output voltage, my dear friends. And V in varies from 30 volts to 50 volts. The Zener diode VZ and the knee current, my dear students, 1 milliampere for satisfactory operation. So what are the parameters he has given? First, we need to write down all those particular parameters, my dear students. Okay, V input, how much V in given? Yes, V in is varying from 30 volts to 50 volts. (30 volts to 50 volts, my dear students. Okay, V in is varying, my dear students. Okay, and here he has given that particular parameter. What I told you, I already told you, this is output voltage is V naught. What is the formula for I? I equal to, my dear students, see here, what I told you, always Okay, the parameter itself is very very important. What is that? V in minus V naught divided by R. This is what I. You're getting the I value, my dear students. Okay, but here the V input, first take it 30. First take this one. For this particular value we are going to do. Okay, and the current. Okay, we need to take any particular current, my dear students. Okay, we can take with respect to the minimum value or maximum value. You can take it IL in terms of, generally what is the formula for current? I am taking one parameter, that is, okay, IL, nothing but IL max or whatever it may be. IL max equal to what is the formula? I minus IZ min. But to get I, which is equal to, okay, IL plus IZ minimum, my dear students. Okay, IZ minimum, my dear students. Okay, so ultimately what I am going to do over here, he only given this is IL value. Okay, and knee current he has given this is IZ min. He has given this IZ min, my dear students. Okay, he has given. Okay, then I am representing here, my dear students, the very very important IL plus IZ min equal to V in minus V naught divided by R. V naught divided by R, my dear students. Okay, then ultimately what happens? Now what is IL? 10 plus 1, 11. This is 10, see here. This is 1, 11 milliamperes, which is equal to V in minus V naught. What is V? Where is V in, my dear students? Okay, that is 30. Okay, 30 is 30, my dear students. And V naught has given this particular value. V naught, how much? As is, yes, Vz. This is Vz. This is nothing but V naught. V naught equal to 10 volts, my dear students. Okay, which is equal to 10 divided by this is what, my dear students. Okay, you are going to get over here 30 minus 10, my dear students. Okay, what I am going to tell you itself is this one, 30 minus 10. Okay, which is divided by R. What is that R parameter? The R parameter we need to find out. He is asking the R value. Okay, he is asking that the satisfactory operation, what is that particular R value? Okay, and that particular value is very very important. Okay, so here what is the value you are getting, my dear students? From this you are getting the R value equal to 1818 ohms. 1818 ohms, my dear students. Okay, similarly, next, similar boy. Okay, see here, my dear students. Okay, what I'm going today is the important thing. Okay, the important thing itself is I'm representing in such a fashion. Okay, in such a fashion. Now the input voltage varies from 30 to 50. Now I'm going to take it again the parameters. Okay, 50. That is what I'm going to get V naught, V in minus V naught. Now V in minus V naught divided by R, which is equal to IL. Okay, plus IZ min. Okay, IZ min. Again here next time 50, 30 to 50. Okay, 50 minus 10 divided by R equal to, again you are getting this one is 11 milliamperes. 11 milliamperes. From this one, what is the value of R getting? R is less than or equal to, so you are getting the R value is approximately, for satisfactory operation the resistance should be always this is your getting is how much? 3636, double, my dear students. Okay, it is becoming the double. Okay, so for satisfactory operation always the value of the R should be less. The minimum resistance I told you, my dear students. Okay, always the internal resistance of the Zener diode should be minimum. So we have to take it this particular value, minimum value. Okay, my dear students. Okay, is that clear? So here the value itself, whatever the value you are getting, my dear students, is very less. Okay, and that particular value itself is R, and that R value is less than or equal to 1818 ohms. 1818 ohms, my dear students. Okay, similarly 1818 ohms, my dear students. Okay, like that you need to do over here in this particular fashion, my dear students. Okay, is that clear up to here, everyone, my dear students? Is that clear up to here, Monica ma'am? Is that clear, my dear girl? Okay. Okay, chalo. Finally, my dear students, we have completed this part of the EDC, and the rest topics, the previous year questions, Monica ma'am, and all those things I am going to teach you in app, the continuation. Okay, that I am going to teach you in the app, my dear students. Okay, I will send you the links. Okay, correspondingly. Okay, thank you very much for attending the today's session, my dear students. Okay, finally, the number of followers in the Facebook are day by day increasing. As far as the Unacademy is concerned, my dear students, Unacademy Telugu channel, Unacademy Telugu channel, my dear students, okay, is you can access the subject in 2 languages, Telugu and English, my dear students. Okay, India's #1 study channels are there, where you are going to access the different subjects for different competitive level examinations, my dear students. And finally, thank you very much for attending this session.